Everyone, let's continue our chapter 1. This is about complex number. Complex number is in the form of a plus bi. A is the real number, so any real number. Bi is imaginary part. So whenever you see I, that's not a real number. So I square is equal to -1. And I is equal to square root of -1. So let's look at our example. I have this 6 plus I, this is my A, and this is my BI. So my B here is 1. This is my A, and my B is 2 here. So let's add like we normally add some number. 6 plus I plus 1 plus 2i. Think of this as like term. So I'm going to add 6 plus 1. 6 plus 1 is just 7. And then I'm going to add the like term here. 1 and 2 is become 3, so plus 3i. So my A is 7, my B is 3. Let's look at the next one. I have subtraction. So I'm gonna do like I normally do. I'm gonna distribute the minus in and then think of combined like term. So I have 3 minus 5i minus 3 minus 2i. Now the real number is the 3 and the 3 is cancelled out. So the real part is just 0. You can think of it as 0. The imaginary part is, think of it as a like term, so you're going to have -7i. You can answer as -7i. That's an answer. But if you want to put in the standard form, it could be 0 plus -7i. That's another way of writing it. Right? So this is a standard form, but they're all the same thing. Now, if you have to multiply complex number, you would multiply it just like any real number. So you're going to multiply the 4 and the 2, that's 8, plus the 4 and the 5i is 20i. The 3 and the 2 is 6i. And this one is 15i squared. Now 8 is just 8. This is, think of it as like term, that is plus 26i plus 15. My I square is -1. So I can have 8 minus 26i minus 15. This should be plus. So I want to keep my real part as my real part and imaginary part as my imaginary part. So this is going to be -7 plus 26i. Right? So it's in the standard form A plus BI. Real part is 7, imaginary part is 26i. The next one, if my C is A plus BI or the standard form, the conjugate of it is going to be A minus BI. If you want to write 5i over 2i in the standard form is A plus BI. This is what you're going to do. You're going to multiply by its conjugate, which is 2 minus I. If you multiply conjugate to the denominator, you have to do the same on the numerator. So I'm going to have 2 minus I. Now denominator, I'm going to use difference of square. Think of A plus B times A minus B equal to A square minus B square. So the first term square, I'm going to have 4 minus I square. That's the denominator. Now the numerator, I'm going to multiply this first term. So it's 10i minus 5i squared. Let's simplify a little bit. So I have 10i minus 5, I squared is negative 1, 4 minus negative 1. I replace all the I squared with negative 1. So I end up with 10I plus 5 over 4 plus 1. Now I'm going to rewrite it this way. 10I plus 5 over 5. Because they want it in standard form, it has to be in the form of a plus bi. So I'm going to write it as 5 over 5 plus 10I over 5, which is 1 plus 2I. Alright, let's see more example. Hi everyone, let's go to our next section. Is inequality. Inequality, you're going to have greater than or equal, less than or equal. So let's look at our first example. I need to solve for x. Same idea as the equal. I want to get rid of denominator. I have denominator here is 2. So I'm going to multiply every single term by 2. So I'm going to have 18x minus 12 greater than or equal to 3x plus 18. Because 2 is a positive number, you don't need to reciprocate the inequality sign. If you multiply or divide by a negative number, the inequality sign will reverse. Other than that, you just solve like equal. Next step I'm gonna try to keep my x on the right hand side, so I'm going to add 12 to both sides. I would have 18x greater than or equal to 3x plus 30. And then I will subtract 3x from both sides. Now you subtract negative number. You don't have to reverse the inequality either. So I end up with 15x greater than or equal to 30. I want to have x by itself, so I divide both sides by 15. So because 15 is positive, I don't have to reverse the inequality. So x is greater than or equal to 2. Now if you're going to graph this, 0 is over here, 2 is over here. X is greater than or equal to 2. So you're going to have open circle, greater than is go to the right. So that's called solution graph. This is called solution set. You're going to write x such that x is greater than or equal to 2. In the interval notation, it's including 2. So you're going to have bracket 2 and go all the way to infinity. Infinity is always parenthesis. This is where you start and it's go on to the right side. Alright, so let's look at the next example. Next example, I have a compound statement joined with the word or. You do the same thing. You're just going to solve this one on the left hand side separately and the right hand side separately. Think of you have one of each side. So I have 3, I have 6, so LCM will be 6. I would multiply on the left hand side by 6 and on the right hand side by 6. If I multiply the left hand side by 6, 3 go to 6 2 times, so I will have 2, 5 minus 3x. If I multiply the right hand side by 6, I have 1. Now it's no more fraction, I just distribute and solve x. Then I have 10 minus 6x greater than or equal to 1. I can subtract 10 from both sides. Again, this is not the only way, but let's do this. So I have negative 6x greater than or equal to negative 9. Now I want to have x by itself, so I have to divide by negative 6. Because I divide by negative number, the inequality sign have to reverse. So it's going to go this way. So x is less than negative and negative is positive. That is 3 over 2. Another word is x less than or equal to 1.5. This is the inequality before or. And I have to do the same to the other side. So I would get rid of denominator. I would multiply by 3. Multiply by 3. This 3 will be cancelled. So I would have x minus 1 less than or equal to 1. No, 3. Multiply by 3. Multiply by 3. One mistake, everything changed. So gotta be careful. Add 1 to both sides. So x less than or equal to 4. Now I have two solutions here, and it's joined with the word or. Alright, so I'm gonna do the graph. I'm gonna have two graphs. One is working graph, one is solution graph. So let's look at my working graph. I have 0, 1, 2, 3, and 4. I'm gonna graph this one first. So x is less than or equal to 1.5. 1.5 is something here. Less than or equal, so you close bubble, go to my left. X, another solution, x is less than or equal to 4, so over here. It's joined with the word or. When it's or, it can be this, it can be this, or it can be both. Think of when it's rain. It's rain from here all the way to the left. It's also rain from here all the way to the left. Where is it rain? Of course, it's rain from 4 all the way to the left, right? So that's your solution graph, from 4 all the way to the left. And the solution interval will be negative infinity up to 4, including the 4. So when it's included, you're going to use it like that, right? So that's the interval notation, and that's solution graph, and that's working graph for the compound inequality. Now let's look at the compound inequality that's joined with the word and. You do the same thing, you solve the one before and after and you put them together. So let's see, I'm gonna distribute the 3 in. Right? Combine like term. Subtract 1. So 3x greater than or equal to 3. Divide by 3. 3 is a positive number. I don't have to reverse the inequality. So x greater than or equal to 1. That's one of my solution. Right? Then I'm going to solve the other one. So I have 3 minus 3x plus 13 greater than 4. Negative 3x plus 16 greater than 4. I like to keep my x on the left hand side. You don't have to, but let's keep it on the left hand side. Negative 16 both sides. So negative 3x greater than negative 12. I need to have x by itself, so I need to divide by negative 3. Because I divide by negative 3, the inequality has to reverse, so it's reverse. So x is less than 4. I have two solutions. It's joined with the word and. I'm gonna graph it first, alright? So let's look at my graph. This is my working graph. I have 0, 1, 2, 3, and 4. X greater than or equal to 1. Close circle, because including 1, greater than is go to this way, to the right hand side. Less than 4, so my 4 cannot be bubble. It has to be open circle. Less than is go to my left. Now it's joined with the word and mean they have to share, right? They have to share, they have to have both. Think of if you want to build a railroad, you need 2 lines. You have 1 line, you can build a railroad. So I'm gonna see if I can build a railroad here. So I need 2 lines, right, to build my railroad. So my railroad gonna start from 1 up to 4, but not including 4. That's the solution graph. And my interval notation will be 1, right? Including 1 up to 4, but not including 4. So it's going to be parentheses. Right? Let's go to the next section. Hi everyone, let's look at our last section for chapter 1. The equation and inequality involve absolute value. So if a greater than 0, so basically a is a positive, all right, and u here is your expression. So we have 6 property here. Let's look at the first one. Absolute value of u equal to a is equivalent to u equal to a or u equal to negative a. This is the first example here. So your u is 4x and your a is 24. 24 is positive, all right? So any number, when it come out from absolute value, it has to be positive. So for this one, I'm going to use the first property here. Absolute value of u equal to a, so u equal to a. So 4x equal to 24 or 4x equal to negative 24 from the first property here. Then I would have x equal to 6 or x equal to negative 6. Alright, let's check it. If x equal to 6, 6 times 4 is 24, come out 24 from absolute value. If x is negative 6, you have absolute value of negative 24, which is 24. Alright, let's look at the second one. I have this absolute value of x plus 4 equal to absolute value of x minus 8. Think of this as u. My first one on the left hand side is u equal to v. So you're going to have u equal to v or u equal to negative v. So let's do that. So I'm going to have x plus 4 equal to x minus 8 or x plus 4 equal to negative x minus 8. Alright, according to my second property here. Now I'm going to solve. Well, this one end up, if you subtract x, you end up 4 equal negative 8. So that's not true. Alright, that's not true. So let's look at this one. So I have x plus 4 equal negative x plus 8. I can add x to both sides. So I have 2x plus 4 is equal to 8. So 2x is equal to 4. Divide both sides by 2. So x equal to 2. Let's check. Alright. 2 plus 4 is 6. That's come out 6, yes. 2 minus 8 is negative 6. It also come out 6. So it work. So make sure you go back and check. If it doesn't work, just cross it out. Alright. So let's look at the next one. Absolute value of 3x less than 12. Let's see. I'm going to use number 3. My u is 3x and my a is 12. I'm using number 3 here. So I'm going to have 3x greater than negative 12 less than 12. Because I want to have x by itself, I'm going to divide everything by 3 and I don't have to worry about reciprocal the inequality because it's positive. So divide everything by 3. So I'm going to have negative 4 x and 4. So x is greater than negative 4 and less than 4. Let's check. It cannot be 4 and negative 4, alright? It has to be greater than, strictly less than. Let's pick a number between these. Let's pick x is 0. 0 is in there. 0 times 3 is 0. So 0 is less than 12. Let's pick another number. maybe 2. 2 is in this interval. 2 times 3 is 6. Absolute value of 6 is less than 12. Alright, it works. It should work. Let's look at the last one. The last one, it's look like my property number 6. My u is 3x minus 3 and my a is 15. So I'm gonna use number 6. Alright, so I'm gonna have 3x minus 3 less than or equal to negative 15, or 3x minus 3 greater than or equal to 15. I'm using this one right here. Let's solve this. Add 3 to both sides. We solved compound inequality before from the previous section. That's what we're going to do here. So 3x less than or equal to negative 12. Divide both sides by 3. So x less than or equal to negative 4. That's one solution. Let's look at the other one. I'm going to add 3. So 3x greater than or equal to 18. Divide by 3 from both sides. So x greater than equal to 6. It's joined with the word or. Remember, or it can be this one, or it can be the other one, or it can be both. So let's look at my working graph. Negative 4, somewhere here, 0, and 6. X less than or equal to negative 4, including negative 4, go to my left. X greater than or equal to 6, including 6, go to my right. Remember, it can be this one, or both. So it can rain here, right? And it can rain here. So where is it rain? Both sides, yes? So if you put in the interval notation, this is going to be negative infinity up to negative 4, including negative 4, union 6, start from 6, including 6, go to positive infinity. Alright, so that would be your solution. We finished chapter 1. Bye.